Good morning, students. Now let's continue with the reactions of aldehydes and ketones due to alpha hydrogen. Before starting the reactions of aldehydes and ketones due to alpha hydrogen, we should understand what is an alpha hydrogen. Alpha hydrogen is that hydrogen which is attached to the alpha carbon. Alpha carbon means the carbon atom which is attached next to the functional group. For example, in the case of an aldehyde, the functional group is CHO, and in the case of a ketone, the functional group is CO group. The next to that, which carbon is attached, that is called alpha carbon, the next beta carbon, the next gamma carbon, like that. And the hydrogen attached to alpha carbon is called alpha hydrogen atom. The hydrogen attached to the beta carbon, that is called beta carbon, beta hydrogen atom, like that it goes on. Actually, aldehydes and ketones undergo a large number of reactions due to the presence of or due to the acidic nature of the hydrogen atoms present in them. The acidity of carbonyl compounds can be well explained by the strong electron withdrawing capacity of the carbonyl group and resonance stabilization. Now let's have a look here. It's the general representation. Here, one nucleophile which is represented by B, polarity is established. So this electron transfer takes place like this. So when an when a nucleophile, when it is approaching here, it takes place like this. And we can see a resonance structure here. Okay. Please write this areas and study. You can see a resonance structure like this. This B, which is represented with the 2 electrons, that is a nucleophile. What happens when it approaches these carbonyl compounds? Next area we have to study is Aldol condensation. What is aldol condensation? Aldol condensation, that is very important for your examination point of view. Aldehydes and ketones undergo aldol condensation. Those compounds or aldehydes and ketones having at least one alpha hydrogen atom undergo a reaction in presence of dilute alkali as a catalyst to form beta hydroxyaldehydes, which is generally called as aldol, or beta hydroxyketones, which is generally called as ketol. This is known as aldol condensation. So once again, let me repeat. Aldehydes and ketones having at least one alpha hydrogen atom undergo a reaction in presence of dilute alkali as a catalyst to form beta hydroxyaldehydes, which is generally called as aldol, or beta hydroxyketones, which is generally called as ketol, respectively. Actually, we need a good practice for writing this. First, let's start with how can we start this aldol condensation reaction with the acetaldehyde or ethanol. I'll explain. Please go through this. I hope that you can see this. 2 molecules of ethanol we need actually here. Should be written like this. It should be split like this. CH3, CHO. Then the second molecule we should split the CH3 like H, CH2, CHO. Okay. in presence of dilute alkali or dilute sodium hydroxide. Now, this is the functional group aldehyde, CHO. The carbon which is next to this is called alpha carbon, and this hydrogen is called alpha hydrogen atoms. Now the reaction takes place like this. Due to polarity, this type of electron transfer happens there. Oxygen is more electronegative, so it pulls electron towards itself. Thereby, this oxygen will be negative charge, and this carbon will be positive charge, and this hydrogen it will be attached to that oxygen. All right. So the reaction takes place like this: CH3, CH. This H will be adding to this O. So OH, then continue CH2, CHO. The name of this compound is 3-hydroxy butanol. 3-hydroxy butanol, that is called aldol. 3-hydroxy butanol or aldol. Now what happens is this compound will lose a molecule of water. That is, one OH is here, one hydrogen will be eliminated from this CH2. So we can write the equation like heat minus H2O, CH3, CH, double bond, CH, single bond, CHO. This is but 2 enol. This OH and this H, water, there is removed here, and hence a double bond is formed over here. So CH3, CH, double bond CH, single bond CHO. The compound is called but 2 enol. So this is the aldol condensation product obtained between ethanol. Similarly, we can write this for ketones also. The same method: CH3, CO, CH3 plus the second molecule should be split: CH2, HCH2, CO, CH3. Okay. So again, double side arrow in presence of barium hydroxide, CH3, COH, CH3, CH2, CO, CH3. That is called the ketol or 4-hydroxy 4-methyl pentane 2-on. This undergo heat. So one molecule of water is getting eliminated here. CH3CCH3, double bond CH, single bond CO, CH3, 4-methyl pentane pend 2,3 in 2-on. Now please look at this equation. So how can I write this for a ketone? So I told you before, the first molecule should be written as such: CH3COCH3 plus the second molecule HCH2, that is CH3, then COCH3. Okay, double side arrow, barium hydroxide or in presence of an alkali. So CH3, COH, CH2, COCH3. Only thing is H should be attached to this. Oh, that we'll write it as OH. Then one water molecule should be eliminated from here. So actually this is the ketone. The name is 4-hydroxy 4-methyl pentane 2-on. This one molecule of water is getting eliminated. So CH3, CA double bond CH, single bond CO, CH3. It is 4-methyl pentane 3-on 2-on. 3 in 2-on. Okay.